going to discuss about the 2011 gate paper previous question with respect to subject of communication system on the concept of PSK or MRAAS, MRAPSK or QPSK. Okay, here a linked question is given. A 4-phase and 8-phase signal constellation are shown in the figure below. Okay, here this one is the constellation diagram for the 4 array PSK, and this is the constellation diagram for the 8 array PSK. Now the question related to the above diagram, the first question is, that is question number 52. For the constraint that the minimum distance between the pair of signal points be D for both the constellation, the radii R1 and R2 of the circles are. So for the given 4 array PSK and 8 array PSK, we have to find out the radii of those circles corresponding to the given diagram, that is R1 and R2. Now the solutions are given like this with different values. Now we'll see the correct solution for this question number 52. Okay, we know that for M array PSK, the phase shift keying, the distance D is given as 2 sin pi by m into root ES, where m is the number of arrays in the given PSK. Okay, now distance of any point from origin is, that is, what is that? Distance from any point of origin is considered as root ES. Now in the given diagram, here the distance from the origin is considered as, here for the first two PSK is R1, and here from the origin at this point the distance is treated as R2. Now that root ES is equal to R1 and R2. Now coming to the answer, here distance from any point of the origin is treated as the root ES. Correspond first circle we consider ES1, and correspond second circle we consider ES2. So that's why for 4 array the distance R1 is treated as the root of ES1. Okay, similarly for 8 array PSK, that distance rate is considered as R2, that is root of ES2. Now we'll calculate the distance D1 and D2 corresponding to 4 array SK and 8 array PSK. Okay, for 4 array the m value equal to 4, then the distance D1 equal to 2 sin, by using this formula, pi, the m value is 4, and instead of ES we will get ES1. Okay, that is nothing but the root 2 sin pi by 4, the root ES1 is nothing but R1. This is the distance D1. Similarly for 8 array, the m value equal to 8, then the distance is considered as D2, that is 2 sin 5 by 4 into root ES2, that is 2 sin 5 by 4, that root ES2 is nothing but R2. Now we'll substitute R2. Okay, if the two distance of the PSK are same, that is nothing but D1 equal to D2 equal to D, then this one D1 and D2 are equal to same D1, then the first this is considered as equation 1, this is considered as equation 2. Now the equation 1 becomes 2 sin the 5 by 4 R1 equal to D. From this R1 equal to d by 2 into sine 5 by 4, that is equal to d by the time sine 2 by 4 equal to 1 by 1 by root 2. This root 2 is cancelled in 2 times, but that is root 2 times, that equal to d by root 2. That value 1 by root 2 value equal to 0.707 d. And next, similarly we will find out the R2 value also. Then the equation 2 becoming like this, that is 2 sine 5 by 8 R2 equal to d. From this one the distance d equal to from this one the R2 value R2 equal to d by 2 sine 5 by 8. Now substitute the sine pi by 8 value and simplify that, then we will get 1.307 d. Now the answers are R1 equal to 0.707 d and R2 equal to 1.307 d. Finally the correct option is in the question, that is D. R1 is 0.707 d and R2 is 1.307 d. Okay, this is the solution for the first question about the linked question. Now coming to the second question, that is question number 53. Now the given question is, assuming high signal to noise ratio and that all signals are equally probable, the additional average transmitted signal energy required by the 8 PSK signal to achieve the same error probability as the 4 PSK signal. Okay, to get the 4 PSK error probability for the 8 PSK, how much of additional energy is required for 8 PSK to get the same probability of 4 PSK? The answers are given in dBs, that is A is 11.90 dB, B is 8.73 dB and C is 6.79 dB and D equal to 5.33 dB. Now we will see the solution. Okay, here the probability of error, that is P of E, is always proportional to the EES, that is nothing but the root ES. Okay, in the previous problem we have seen the for 4 array PSK, that the probability error is proportional to ES. Now we have seen the for 4 arrays K, that is ES1 we have seen, and for 4 array PSK and root ES2 we have seen. Okay, that root ES1 is considered as the R1 and that root ES2 is considered as the R2. Those are the radii or distance from origin to any point on the circle. That R1 equal to root ES1 and R2 equal to root ES2. Okay, these are the energies corresponding to the 4 array PSK and 8 array PSK. Now we will get the ratios of R1 by R2, that equal to root ES1 by root ES2. We already solved in the above problem that ES1 by ES2 equal to R1 by R2. We got R1 value and R2 value. That R1 is 0.707 D and R2 is 1.307 D. Now we require the ratio of energies for the 4 array PSK and 8 array PSK. But here we have root. Now squaring on both sides. Then we will get ES1 by ES2 equal to 0.707 D by 1.307 D whole square. This D cancelled out. Now we will simplify these values. then finally we will get 3.42. This is the ratio for the energies of 4 array PSK and 8 array PSK. Now to get the same error probability, the ES1 should be equal to 3.42 times of ES2, where ES2 is the energy for 8 array PSK, ES1 is the energy for 4 array PSK. I already said the probability of error is completely directly proportional to the energy of the circles. Those, that is, from this one we can find out the energy. Okay, for this energy just apply ES2. The ES2 requires the additional energy of 3.42 times of 4 array PSK. Now apply the 10 log 3, the value how much it is extra is required, that is 3 energy 3.42 base 2, then we will get the answer 5.33 dB. This one. Okay, this is the energy required. Extra energy is 5.33 dB is required to get the same probability of 4 array PSK. Okay, the 4 array PSK is considered as the R1, that is ES1, 8 array PSK, that is R2 ES2. The ratio of R1 R2 already we got. From that we got the relation ES1 equal to 3.42 times of ES2. Okay, that is nothing but the probability error of E1 is 3.42 times of probability error of 2. Okay, to get the same probability of first one, the second one should be 3.42 times. Okay, this 3.42 times is converted in the decibels, we will get the 5.3 dB. Okay, the 5.33 dB is the option, that is nothing but D. The answer is D.